In one of our recent videos, we looked at the 3GPP RAN 1 status of 5G NR, new radio, standardized by 3GPP. And we discovered that there has been a decision on the working assumption with which subcarrier scaling to work. And I want to show you how you can use a Roden-Schwarz signal generator to mimic that and to create a signal like that. So let's go into the generator. You basically see here the graphical user interface. And I already prepared the signal here, and I just want to walk through the signal with you. So what I basically did is, within the baseband of the instrument, I'm choosing 5G waveform candidates. And Roden-Schwarz implemented that with the start of the research in 5G. And you see here we implemented certain waveforms from the 5G Now project, UFMC, GFDM, etc., but also filtered OFDM. And with the right settings in filtered OFDM, for instance here for the filter length 1, and then for subband length also 1, we generate basically generic OFDM-based signals. And that is something that we can use to now mimic these signals that currently being discussed in RAN 1, at least from a subcarrier spacing point of view. So let's take a closer look. My example here, I'm defining an FFT size of 2048, as you can see here. I'm using 1200 occupied subcarriers. I decided for a subcarrier spacing of 240, which is one of the options within the current working assumption. You see my sequence length to be 14 symbols, and I'm using a cyclic prefix of 160 samples. So down here you can see basically the configuration. I have a sampling rate of 491.52 megahertz and an occupied bandwidth of 288 megahertz and a number of unused guard subcarriers left and right. So this is basically the basic parameterization of the signal that I would like to use. And now that I'm being able to demodulate with the FSW and K96 OFDM vector signal analysis software, I need to do a few twists to that signal to make that happen. So therefore, I'm looking into the allocation tab here. So I'm closing these windows, and I'm opening up the 5G waveform candidate option again, choose allocation settings, and then basically go into the allocations. And for the simplicity, I just did here 2 allocations. So very simplistic. I'm using a BPSK modulation and 5 of the 14 symbols available as pilot sequence. That's the plan. And then I'm using a 16 QAM modulation on the entire bandwidth with 9 symbols and an offset of 5 symbols. So basically, in the beginning of my frame, I have a pilot sequence, and then I have a bunch of symbols that are carrying data. So I can look here at the time plan again to just visualize what I said. So you see that basically here, my pilot portion of the signal and my symbol portion. And now I'm basically ready to go. I switched on the waveform for you already. And basically I pick a frequency and a power level, which I did here as an example with 28 gigahertz and 0 dBm. And now I would be ready to go with the signal. And I can also start configuring a configuration file for our K96 software for OFDM signal analysis that tag teams with the FSW signal and spectrum analyzer. But this is a topic for another video in our video series, Demystifying 5G.